Hi, I'm TJ and you are watching a new video on Mastercam Multiaxis tutorial. The topic today is how to use the T-plane transform function in Mastercam for multi-axis work. In this video, I will show you how to do this. The Mastercam T-plane function is a part of toolpath transform in Mastercam. You can find that on the toolpath here. In the previous version of Mastercam, here is the 2017, and in previous version you can find that in the toolpath menu and click on the toolpath transform function. The T-plane transform option allow you to transform the toolpath by changing the T-plane or toolplane, so you can create multi-axis indexing without using two multi-axis toolpath. So in this case, you just create a 3-axis toolpath and then you use the toolpath transform to rotate the toolplane to create a multi-axis work. So don't need multi-axis toolpath. Okay. The T-plane transform work rate on the part have symmetrical face, symmetrical entity like this part. You can see we have some symmetrical entity like the square entity here, the square flank here, and the hex flank with the 3 hole set apart 120 degree. Also we have 2 slot and set apart of 180 degree. So that's great when you use a toolpath T-plane transform. And you can see here in this part I have a gear section here with multiple gear teeth, and I will also use the T-plane transform to machine these teeth. Okay, I will show you all of them in this video. And here's the sample part you can see on the screen. This part is previous create on the lathe on turning function. So after we have the turning part, we mount the part on a 4-axis machine using the 3-jaw chuck. The chuck will grip on this cylinder and we machine the remain section here. Okay. Before I create a toolpath, I want to show you how we can create the stock by using the turn profile function. In the previous version of Mastercam, you can find that by clicking on the create menu and select the turn profile. Okay. This function allows you to create the turning profile from a milling part. Okay. I click on this. Before I do that, you can see I go to level and you can see that I just created 2 levels. The level 1 is for the part and level 2 is for the stock. So I'm creating the stock, so I select the level 2 for working. Okay. After you select the level 2, I select the turn profile function, and I'm gonna click on our part and then click on enter. So I select the spin. Mastercam will spin the part and find the turning profile. Okay. After that, I select the axis to select the axis which Mastercam will use to spin the profile. Okay. Click on this and you select. At first I select the center of this circle, and after that I select another center here. So we just create the axis, and I'm gonna click on OK button. Okay, now you can see I have the turning profile created. I will hide this part for you to easy to see by hide the part. So after you can see, after use the turn profile function, I have a turn profile here. And the next step to create a stock, I going to do a solid revolve function to create a stock. Before doing that, I need to create a axis for revolving operation. Okay, we will turn on the park. You can manually draw the axis, or you can use the modern prep function, hold axis here to create this axis of the hole. Very simple. I just want to create axis, so I will deactivate the point and circle, only axis. Click on this and click on the OK button. Now you can see I have the profile and the axis. The next step, I want to do a solid revolve function. Ping, yes. You select the profile and you click OK. And Mastercam will ask you to select the line to use as axis of rotation. Then you click on this axis line. Ping. Yeah, that's cool. So you can see we can easily create a stock for this and click on OK. I can use the modern prep version and remove the history of this solid. So I can remove the profile and the axis. Yes, and now I just have the solid only. So you can see the stock and the park. Stock, the park. I will change the color of the stock to green. Okay, the green. Okay. So now you can see the stock, the park, stock only, and the park after machining. Okay, so we have both the stock and the park. So I'm going to the toolpath here. Before you do the job, you need to select the right machine for the job. For this job, I can select the mill 4-axis VMC machine. Okay, you can see here this machine I have selected, and then I will use the stock setup to define the stock. In this case, we just create a solid, so I will use the solid function here, and I click on this button to select the stock we just created. In the reverse tab, click on this. You can select to display the stock or not, like this. Okay, and now I can hide the stock level. Don't need it anymore. Just you to select. So you can see here we have the stock and the park. You can hide the stock if you want by uncheck this function. Okay, the stock has been high, so now you can see the park only. And before creating toolpath, I want to show you some tool that I have. Okay, this is the toolpath, the tool manager. I have some tool here. A 1-inch flat 10mm to machine the flat area on the park. A 1/4 mil to machine the slot on the park. I have 2 slots here, and I can machine it with a 1/4 mil. And I have a spot drill to drill the spot drilling the hole here. Also have the a 1/4 drill to drill 3 hole here, and I have a gear teeth cutter to machine the gear teeth here. Okay, this for information purpose only. So I won't create the rough operation, the semi-finish, or the finish. I just want to show you how to use the T-plane transform. So I don't want to use too much, so many tools for the job. That's take a lot of time. Okay. Before you use the T-plane transform, you need to create the first toolpath, or the main toolpath to use for transform operation. Okay. The first thing I want to machine on the park is maybe let me see. Okay, I can machine the flat surface on the hex section first. This one. Okay, I will use the 1-inch mill to cut this flat surface. I'm going to the toolpath and select contour. Because there's no curve created on the part, so I will select the solid option to select the chain to machine. Okay, I will select the single edge here, and I select this edge. Yeah, okay. And then I select the tool. We use the 1/8 tool for this. You can input the speed, the bit rate. I will skip it in this video. Okay. You can select the composition file type. Okay, in this case we select the RAM option. Maybe you don't need if the material is not much. Alright. Depth cut if you want. Let in and let out. So 0. Okay. 0.5. Linking parameter. I will select the depth of cut. Select here for the depth of cut. And I select the top of cut. If you want the feed plane, the retract plane, and the clearance, for example, 5 in absolute. Alright. So you can see we just created contour toolpath, or maybe we need a little bit additional lead in and let out motion. For example, 0.75. Okay. Thing, yes. You can see that we just create a base operation before we do the transform. Okay. And now it's time to do the first transformation. You can see we have 1, 2, 3, 4, 5, 6 phase need to be machined. So that's what I'm gonna to do now. I'm gonna click on the toolpath transform here, and to rotate the tool plane you must select the rotate type in the type area here, and the method you must select the tool plane. In the tool plane you have some more option that include origin, include work coordinate system, or safe plane. Because in this part we use the same origin and the same origin that's in the center of part, so we don't need to select this option. If we create a new origin or new work coordinate system, that's we don't want. We just want to rotate the plane, the tool plane, so you don't need to select this option. You can select the source of the transform, the NCI or the geometry. Maybe you don't need to care about that. If you don't know what this means, just click on the question button here, and you go into the see field definition. What you don't understand, click on this. So for example, NCI or geometry, yeah, it's up to you. If you care about it, you can select this button. Alright, and you can see here sort operation. So I want to rotate this first operation. I select on this, and on the right side you have a few options: the create new operation and geometry. So if you want to create a new operation and geometry like this, you can check on this. In this case I don't want to do that, so I left it unchecked, and you can select copy sort operation. So the sort operation will merge into the transform operation. If you select this, you can check it. I will check it later to let you see what is the difference. Okay, now I left it unchecked. If you want to create a subprogram, you can check on this. And here you have a option called work offset numbering. Maybe you know about the work offset, like something like G54, G55. So if you want H rotation, I have a specified offset number you can check on. automatic. Or if you want to maintain only one work offset, like you only want one G54, you should check on this. So Mastercam will just rotate the just change the angle. It's not change the work offset. So you only have one G55 or one G54. It depends on the sock operation. Okay, this will maintain the sock operation, work offset while we do the transform. Okay, and in the rotate tab, you can see that we have some parameter here. The first here is the number of entity you want to rotate, you want to create. So I have already machined this face, so I just want to create 1, 2, 3, 4, and 5 more entity, 5 more rotation. So I input the 5 here. You can select the angle between or total sweep. If you select the angle between, you must input the between the angle between two face. For example, I select angle between. This is the start angle. This is the sock operation phase. So the start angle we want to do the rotation must be 60 because this is a hex phase entity. So I will input 60. We skip the first sock operation. This is the 0 angle, and for the first entity here, that start with the 60°. So and here this angle depend on what option you select here. If you select angle between, so we need to input 60 here because we have this distant angle from this face to this face is 60° because this is a hexagon. Okay, and if you select the total sweep, you need to input 1, 2, 3, 4, 5, and total sweep is 5 multiple by 60, that is 300°. Okay, and one important thing you need to take note of is the rotation plane. If you don't select the rotation plane, the toolpath will just only rotate in the tool plane here, and you will don't have a multi-axis index. So you need to select the rotation plane by clicking on this. And in this case, I think you can imagine what is the rotation plane here. That we need to select the right. Okay, you can select the right side or the left side. It will the right rotation plane because you want to machine these 6 faces, so it need to be rotate around the x-axis. So I will select the right side here, and I'm gonna click on OK when you're done. Yeah, you can see the tool path have been rotated around the x-axis. That means the rotating plane is the right side or the left side. Okay, I will show you how it works. Ping first, and then the second, the third, the fourth, and the fifth face. So you can see that our toolpath have been rotated in the right side plane. Yeah, and if you want to select the angle between, I can input the 60 here, and you have the same result like this. So the angle between each rotation is 60°. It's the same. And if you input 0 here, this start angle, you can see the first toolpath will the same with the sock operation that you don't want, because in the first operation we already machined that face. So in the transform we don't want to machine it again. You can see it, we don't want to be machined again. So the start angle must be set for the next plane, that is 60°. If you input a negative value here, the transform will do in a different, yes, this one um, uh, direction. You can see here. So if you want to machine it revert, you can input the -60 here, and the part will be rotate in a reverse. Yes, you can see it direction. We machine in the clockwise direction. If you want to input a positive value, the transformation we do in a different direction. It's depend on the tool plane, the rotation plane you selected. If you want, if you select the left side, it will rotate in a different direction. So if you don't, I will show you what happens if you don't select the rotation plane. You can see the tool path has been rotated on the original tool plane, that is the top plane, and you don't have a multiple, you don't have a indexing, a multi-axis indexing. You just have the normal transformation. It's all happen on the one plane. That's what we don't want. So you need to select the right rotation plane. In this case, that is the right side for all, for remain operation we do later. Okay. And if you want to copy the stroke operation into the transform, you can select this. And you can also select this option to disable posting the stroke operation. You select this. When you post the NC file, the first operation, the stroke operation, will not be export. You can see here we have a ghost face here that tell you that when you export the NC file, this operation is not going to be export. So you can see if you copy the stock operation, the first plane here will be show also. Yeah, the first, second, third, fourth, fifth, and the sixth phase. So I will show you in the verify. This gonna be a long video, so while you're watching, you can prepare a cup of coffee so you will not get sleepy. Okay, please wait a minute. Okay, we hide the workpiece, and for the first operation I will show you. Yes, did the first phase, and then the park rotates. What happened here? Maybe the tool. Oh, what happened? Uh, oh, it's just about um, the definition of the screen. Yes, the second phase, the third phase, the fourth, the fifth, and the sixth. Okay, we need to recheck, double check it. There's some error here. This because the resolution of the screen, not about the toolpath. We can increase the rest, the precision of the verifying. I will make this the tool stay fixed. Okay. Okay, redo it. This machine is too slow. Alright. Okay. Zoom it a little bit and I will show you first, second, third, the fourth, and the fifth, and the sixth. Yes. So we have already machined the hex function, the hex section of the part. So the next, I will keep using the 1" flat 10mm to machine the square section here. So you can see we have a square section. Alright, I will copy this operation and I reselect the chain, rechannel here, and I will do the same. I will select this chain for machine and click OK. I generate the toolpath. Okay, you can see I do the cut here. To make it different, I can select the ramp, the plung ramping here. Okay. And select the top of stock here. Yeah, top of stock, and the depth is in incremental. So you can see the difference in the toolpath. And ting, plung, go to the right, plung, go to the left, right, left, right, left, right. Okay. Yes, after create a toolpath, I do the transform again. You can copy this and change the parameter, or you can select a new toolpath transform. And in this case, I keep the parameter on the left. I just select a new toolpath. Yet I select the number 3 toolpath here, the contour ramp, and any other parameter I keep the same. In the rotate, I need something to change because this is square. I just only need to rotate 3 times. Alright, and the angle I set first is 90 degrees, and the angle between is also 90 degrees. Because this is a square, not the hex anymore. The rotation plane, I will keep it to the right side, and I will keep it for other operation. Okay, now we can see the first operation, second, third, and fourth. Because you have select visible posting in the selected short operation and copy short operation, so you can see the number 3 operation here had been killed, and it will merge into the 4 operation. You can see here this is the third operation. It has been merged with the transform, so we have a 4 rotation at a time. Bing, yeah, that's cool, right? Okay, maybe when we will save time, I will do the verify later. Okay, and maybe you might have maybe you have remember something about this. Okay, we do it again with the slot. All right, I will use the slot milling toolpath to machine this slot. Okay, we have no curve, so I select the loop option to select the slot the slot profile here. I'm gonna click on OK. Okay, and I select the quarter and mill for the slot milling. The cut parameter. Alright, input some parameter for the slot milling. Alright. Okay. Ram. Angle for the ramping motion. And the step over for the roughing. And the step over for the finish part. Finish pass. Keep tool down to avoid retracting the tool. And break through maybe 20 tiles. Okay, and the linking parameter, I will select the depth Okay, I will select this point for the depth, and the top stop we will select uh, this point. Okay, the clearance 5 inches. Alright, and here's the our slot milling toolpath. After create the slot milling toolpath, I will use the transform and rotate again. And click on the toolpath transform, select the fifth operation slot milling here. But in this case, we only have 2 slots instead of 4. So you need to change the parameter in the rotating tab. So I have only 1 because I have already machine 1 and I only have 1 need to be machined. So I input 1 remain, and the angle, the start angle is 180. So with the one entity, you don't have the angle between, only the start angle. Okay. Okay. And now we see what we got. Ping and ping. Yeah. If you don't want to merge the operation, the stock operation, you can uncheck this. So you can. So we only have the transform toolpath like this. Yeah. And this is the stock operation. The stock operation. Yeah. Okay. That I'll show you the difference when you select the copy or sort operation, or when you unselect this. Okay, and we have already finished the slot. Okay, and the next thing we need to drill the 3 hole here. But one thing you can see that the hole is not located on the top plane. When you see on the top, you can see the hole is not located on the top. That's not say perpendicular to the top. So in this case, I need to create another tool plane. First, to do that, I go into the plane. Where's the plane? View and select plane. Okay, we go to the plane, and I will create a new tool plane for one hole. Any hole if you want. For example, I can create a tool plane for this hole. I click on the plus button here and select from solid face. I click on this face, and you can see that the X direction and the Y direction is dry. So you click on the agree button here. You name it A60. Okay. And we want to move our origin of the plane. Okay. When you click OK, you can see I have created a plane. But I want to move the origin. We have the right direction, but we want to move the origin to the same origin with other operation. So I'm going to right click on this and select edit. You select the origin and move it to a new location. I will select the center of the park. So yeah, you can see this is the top T plane and this is the A60. You can see they have the same origin like we do on the 4-axis, like the normal way we do with the 4-axis. Okay, and I select this at the tool plane and C plane. Okay, and I look from the top. You can see now we have the tool plane A60. So we can create the drilling operation after we create the tool plane. Alright, to save time I will ignore the spot drilling. I just want to drill with the quarter drill only. So I will skip the spot drilling process. Okay, I select this hole and I select the tool, quarter, drill, select the drill operation, and the retract, the clearance, the retract, okay, top of stock, and the depth, for example, 0.20, point, okay, and let me see the toolpath we just created. Bing, oh, where the tool? Oh, what happened? Sorry, I missed the decimal point. My fault. Okay. 0.375. Oh my god. Okay. Ping. 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 Yes. Oh, I go too deep, but no worry. Just for information. Okay, you can see I have created the toolpath for the first hole, and we do the same to create a toolpath for the remain hole. Okay, toolpath transform again, and select the seventh operation, the drill counterboard here. And in this case, yes, what parameter we will input? I have created one hole, so I need to create more two hole, and the start angle will be 1 2 3, so the start angle will be 120, and the distance between angle between is 120. Very simple. So if you input the angle between this, normally the same with this. If the part is symmetric, the entity is symmetric. Okay, let's check it. Boom, yeah. And if you want to merge in one operation, skip on this. Ping, and yeah. You have 1, 2, and 3. Okay, we had already done for the drilling. Very simple, right? Okay, let's do the verify. Ooh, alright. Keep the workpiece fixed. Alright. Go. Ping, ping, ping. Alright. This is for the hex. And next, this is for the square, the ram contour, and then we rotate it 90 degree and 90 degree again, and again 90 degree. So we have the square. Okay, and this is the slot milling at 0 degree, and then after that we rotate the tool plane 180 degree to machine the slot on the bottom face. Okay, you can see that's very simple to create an indexing work by using the toolpath transform. Okay, and now for the drilling operation. The first hole with the A60 tool plane, the second hole, and the third hole. Alright, this is the part after facing and drilling and slotting. Okay, the final step we need to do is cutting the gear. Yeah, this is very beautiful part if it don't have the gear teeth. So I will show you. All right, let's take a look. Let's take a look from the right side. I need to select the top plane. Okay, and then we look from the right side. You can see I have a gear here. This gear is have a 40 40 teeth. So later we will transform with this number entity. To use this to cut this gear, I will use a custom profile tool I just created before. This is the tool. Yes, this is the tool to cutting the gear teeth. You can download the profile of the tool on the tool maker like Iska or Goering or Sandvik. They normally have the tool profile for their product. You can download it and use it. Okay. Before I cut the gear like the previous operation, I need to create a sock operation. So let's take a look on the right. You can see we need to draw a contour for the gear. Okay. You select a gear tooth that is stay horizon, and you draw the line. If no tooth stay horizon to the tool plane, you need to rotate the tool plane to create a new tool plane to create a, a soft contour tool path. Because in this case, I have this tooth has already stay horizon, so I can use this at the soft operation. Okay, and again we use the contour tool path, contour, and because I have the curve already, I can select the chain like this. Alright, bing, and I select the tool, gear tool, teeth cutter. Before you use the tool, you need to know the distance from the center of the teeth to the bottom of the tool. It depends on where you set the tool height, so you need to know that distance. In this case, for example, is the 0.107. Yeah, you know to need the distance between the bottom to the center of the teeth. You need to know that. Okay, select the tool and the contour type, the tool plane. I will select the top. Okay, and for example, multi-pass need 3 rough. I will make cut it one teeth in 3 pass. I keep the tool down and I input the let in and let out motion. Okay, and the linking parameter, for example, incremental. Yes. Okay, you can see I have just created the tool path for the gear teeth. Let's take a look from the right to see if we input the right depth for the tool. And yes, let's look great. Okay, you can see I just create the tool path for the one gear tooth, and we do the transform again. Go to the tool path transform here and select the night operation. And okay, this is the fun part. We need to input the remain tooth teeth need to be machined because this is a 40 teeth gear, so I input 39. We need 39 need to be okay. And for a 40 teeth, the start distance may 360 divide by 40, so we get 9 degree, and the distance between x to the 9 degree also. Bing! And let's check it out. Let's check it out. So you can see we have the tool plane rotation like this. for the gear. Okay. Let's do the verify. Alright. We will do the fast forward for the previous operation. And now it's time for the main event of the evening. Okay. It's time! This is the first teeth. That's the first tooth of the gear. And then I'll keep the tools fixed. Okay. And then we got ting, ting, ting. Yeah. Again. Ting, ting. And okay, I will show you. And, oh, the machine is too slow. I'll keep the workpiece. Yeah. That's the transformation. Ting, ting, ting. This is the workpiece. You can see. Exactly. Right? Beautiful. Okay. We can try with the machine simulation. You want to do that? Okay, do some setup. Okay. Collision, you know what? Because the simulation is not so good. Okay. Just ignore a collision because this not run true when you put this on the machine simulation in Mastercam. It just show you how it work on the machine. And this is a square. Yo, it's fast. You can see the collision. And this is the gear cutting. Oh, my boss will kill me if I make the part like this. It's totally destroyed by the tool and collision. Oh my god. Yeah, this is the gear cutting process. I will slow it down. Yeah. Okay, that's all for today. I hope you can learn something from this video. And I'm still learning the multi-axis and have not much experience on this, so I want me and you can learn it together. Okay. If you have any comment, please leave it on the bottom of the video. Okay, thank you and goodbye for now. Bye bye. Good night.